First we will define what is a column space, and then we will see how to find its basis and dimension. Given a matrix A with m rows and n columns, say its first column is C1, second column is C2, and the last column is Cn, then the column space of the matrix A is the vector space that is generated by the columns C1, C2 up to Cn, meaning that column space of A is the span of the vectors C1, C2 up to Cn. For example, we have a matrix A 2 4 0 4 2 5 1 4 -2 -4 0 -3. Then the column space of this matrix A is the vector space that is generated by all columns, first column, second column, third column and fourth. Since these four vectors could be linearly dependent, so therefore this is not necessary that these vectors are the basis for this column space. So to find basis and dimension, we will find a row reduced echelon form of the matrix A. First write the matrix A and divide first row of this matrix by 2 to get 1 at the upper left corner of this matrix. In the next step, write first row as it is and perform the row operation on second and third row. R2 minus 2 times R1. R3 plus 2 times R1. And get the following matrix with these pivot points. Then basis of the column space consists of the pivot columns, which are 1 0 0, 2 1 0 and 4 0 1. So we see that column space is generated by 4 elements, but in fact only 3 vectors are linearly independent. So these are the basis of the column space. The column 3 0 1 0 can be written as a linear combination of column 1 and column 2. So it means that the third column is linearly dependent on column 1 and 2. And finally, the dimension of the column space is the number of pivot columns in the row reduced echelon form, which is in this case 3 because we have 3 pivot columns. Let's recall everything. The column space of a matrix A is the vector space that is generated by all columns of the matrix A. That is the vector space generated by column C1, C2 up to Cn. And to find basis and dimension of this space, we simply row reduce this matrix A and just concentrate on the pivot columns, and pivot columns form the basis of this column space, and the number of pivot columns is the dimension of the column space.